This is our starting page, which is the index page. It is where when we type in our IP without any backslash, it will be the one that pops up. This page is just like a lobby before you can access the system by login. And if you didn't register your account yet, you can register your account by clicking the register button in the right side here. And if you already registered the account into the system, just click the login button here. The design of this website, we keep it simple so that it doesn't confuse you too much, and just get straight to what you want to do with this localhost website. And we also use React for the library to use with our design. Now let's get started with the next step. For accessing the website, let's click register here to register our account in the system.
Now let's talk about the register page. This is the page that you will be met when you click on the register button from the index page. But if you somehow already registered to the website, then we have an option under the register button to lead you to the login page. Now let's move on to the main point here. As you can see, we have many things to fill in, such as first name, last name, factory ID, email, date of birth, password, and confirm password. And if you notice, we have used the special class that allows us to input a consistent date of birth format by making the user select date of birth from the calendar, and we also utilize the .getFullYear function to get the current year from the library that Python has. Before registering, we want to point out our failsafe function in this system. If you type in the same factory ID or the same email, it will show up as you already have factory ID or email registered, depending on what data you type in. This functionality is one of the main components inside the API users create API. We will then use the fetch function to fetch the data from this API. Inside the API users create browser, it has a response model which will collect all the data that we want from the database. We first create a class named user_response that contains all the data that will be responded with inside this class. It doesn't contain password due to safety reasons, and the reason this class is created so that my register website, when it uses the first function, it will get the response from this format data. Then we will be utilizing it with the response model variable, and inside this router, it will use an asynchronous function called createUser. That we create inside this createUser's properties. It has two failsafe check, which is the existing factory ID and existing Gmail. This data is all import from the database.py. It can check by sending query with a function to get all the data with this factory ID or email. If it already exists, the error will then raise and the data will not be submitted to the database. But if it passes all the failsafe, then the data will be then sent to the database. This is the check of failsafe that we have for API. And we also have one failsafe check for the website as well. It is failsafe for age checking. It checks by getting the current year minus your birth year. If the result is less than 18, it will show a stack bar message that says you are under 18, you cannot register this website. Now, after you click register, two things will happen. The first is your data will be saved inside Pinot table, and inside Pinot table, it contains all the data that you view, which I had mentioned earlier, and also user ID, password hash, and timestamp. The user ID is the order which the user registered an account into, and the password hash is the password encryption It works as a safety when you key the password into the table, which prevents data breach in case of that ever happened. And the timestamp is the current time when the user registers the ID into. And the last thing that will happen is that you will then redirect to the login page.
So now we are inside the login page. Inside the login page, there are three inputs that you have to put into before getting inside the main page. The first input is a factory ID. The next one is a password, and the last one is a captcha, which is just a basic math that you have to answer correctly, and it also random every time you go login page. So for API, the login page will fetch the data from /API/users/login with token API. In this API, it contains four main functions. The first one uh, is to check for the password, which is called verify password. And the second one is used to check for the factory ID, which is called get user by factory ID. Both of these will raise an error when one of them is missing. And the last one is authenticate user, which check for both password and the factory ID. It will check that the password and factory ID is matching or not. If not, then it will raise an error. Now the special thing about this API is that the function called create access token and store token. So for the create access token, what it does is it will create a token every time you successfully login into the system. This token here work as a key to access the log website that require login to access. This key will only last for 30 minutes, and after it expires, when you access the website that requires this key to enter, it will then automatically log you out and put you back to the login page, and you have to log in back again to enter the restricted website. Now back onto the login page website. After you click login, you will then link to the main page of the website.
Now this is the main page of the website. You will be direct here after you log in. This page also has a token checking system, which is in the userFetch command. This command will run every time we use this main page to check that you have the token or not. If you don't have the token or your token is expired, the website will then automatically redirect you to the login page. Now, for this page, I provide a brief overview of the Pi game. This is our algorithm project that we had used it to be integrated with our Compro project. Not only that, we also have three special buttons with each of its own function. The first button is on the top left corner, which will lead you to the profile editing page. And if you notice, next to your profile icon is your name, which is displayed according to the data that is pulled from the database. It got this data from fetching the API/user/me. This API works by pulling the current user that has a token, and the second button is the yellow button on the middle of the screen. This button here will lead you to the dashboard/PyGameViewer section page. And lastly, the top right button from this page is the logout button, which works when you click the logout button. It will remove your token from you, and you will be then sent to the login page. So, next one. This is the profile page. Inside the profile page, it contains your current information that the website fetched the information from. The information of the website is respect to the one that you had logged into the website. In this profile page, not only it can tell what is your current information that you could also edit your profile here as well. So for fetching the data from the database, it used the /API/user/me API to display the current data inside, and we then use the /API/user/data API to update the data that's changed. We also have a hardware change. We also could change the password We can do it by edit here for the profile. We can absolutely change everything except for the factory ID. Here is the dashboard page, the page where we use to gather the information from the Pygame app. The app are run locally, not directly from the Docker files. I will explain the part where we pull the data from the Pygame code to the website. First, before we can explain how the website works, to make sure it's more understandable, or if you want to know the full detail of the Pygame code, you can visit our YouTube link here. Here are all the things that we have added to the Pygame code. In the first line that you see here is the variable declaration. It is used for declaring the data to start from 0. Even though it is normally start with 0, but we use this just in case it isn't start with 0 for safety measure purpose. Now, the next function that I have defined is send underscore game underscore stat. The send game stat function here is used for sending the game stat to the API of the website server, which require a URL to send the game stat to. The URL are as follows: ws //localhost 8000 /ws /gamestat the socket data. And under this URL is a loop function. Inside this loop function is had try and another loop inside. Inside the try is a variable declaration which declare ws as websocket and bracket, and then run the ws.connect. Inside the bracket it has a URL. It's a function inside the loop, and this ws.connect bracket URL is used to connect the API website. It will then run the print connect to the server command to indicate that this loop runs perfectly fine. And under the print command, it has another loop which used as the constant variable declarer to update this data to the socket link. Not only did it constantly send all the variable, it also sent the image from Pygame to the website as well. This function is the get underscore frame underscore image function, which we then declare as image data to then put inside the data packet. Inside the data packet, it has two variables. The first one is the stat variable and the frame variable. The stat are the variables such as the quantities of an item collected or the robot traveling distance, item collected from each robot, or the item collected from the target. It is all the data need to be collected, stuff like that. That is all data that we put inside the data packet dictionary. We then use the command ws.send JSON dump data packet to then send all of the data inside the data packet dictionary with a delay of 0.1 second for smooth experience. So for delay part, it actually is for the frame rate. The higher the slower the frame rate gets, the lower the value, the higher the frame rate gets. Now you might have question why we try to run this loop command, and the answer is that there might be some time that the data is not sending to the server and will show up an error, and when that happens, the program will then automatically shut down. So that's why we use the except command to ignore the error and keep persisting to run and try and run the loop again with a delay of 5 seconds. Now let's look at inside the get underscore frame underscore image function. This function are what used to send the Pygame data to be sent as an image format. For the frame underscore surface, quotation frame underscore string and image variable are all used to set up the Pygame image. And the next is the image.resize variable, which used to set the image size for sending it to the website server. And under the image is the other setting for sending the image to the Pygame, such as image process to increase the quality of an image. But the problem is that it will also eat too much of our PC spec, so the quality of it is 50. Because 50 is fine by itself, it doesn't eat too much spec of your PC. So the buffer variable that you see here are used to send the temporal data so that it doesn't fill the memory of our PC. We then encode the image to then be sent to our website to decode the image and then show it through the website. We then run the send underscore game underscore stat in a separate thread because it is used as a loop function. Then the current loop function is the main Pygame loop, which it will disturb with each other if we didn't use threading. So that is why we need to use threading for this occasion. That is all the modification that I had made to the algorithm project to work with the Compo project. And then let us go to the website part. Now let us get back to the website part. This website also has a token system as well in the user effect here. As you can see from the website, here it is just a small shell or a box without any data input into this. Now this is what happened when I run the Pygame program. As you can see here, the data all of them is shown here on the dashboard website, even the display as well. I also had a graph provided to show each of the information that I want to, and I also had a graph for the performance robot for each of the categories. Now for calling the variable, for example, I want to call the quantities data, which is the one that I declare from the Pygame. When I call this data, it will show the current quantity that I had in my Pygame. With this information, I could call in any data from Pygame that I want. But from what you see here are all the data that I call from Pygame. Now, after the game is done, as you can see, the time spent to finish will pop up. That will happen. Now, I will click Submit Data button. So for the functionality of this function, it will send all the data that we want to send from the handle submit function here. It also has a failsafe that in case that the token is gone while we are inside the website, which will raise an error saying that you need to log in before submitting data. And you will then be put back to the login page. This handle submit code will send all the required data to three table. Each one of has its own column for data filling. Now for the API that I use to submit this data is the localhost 8000/API/submit.gamestat, which is located inside the app.py here. This data could later be used to analyze each of the robot. When we submit the data to the table, it will also has the same exp underscore number too. This exp underscore number variable are a variable that is located inside every stat of my data table for my Pygame. So it is the same as experiment number. It actually an experiment number that function that we use to show that the data that I send is with what experiment that it is related to.